So in today's lesson, we'll be doing organic reactions, and this one is from the trial exam. What I like about doing the trial exam is that you guys already tried them already. You've already worked on these questions, which is good. So that way I'm not only just solving something that you haven't seen before, something that you haven't attempted. So that's a good starting point because already now you know what you struggled on, and then you can be able to learn from that. All right, this is the trial one, and this one here is from the November 2023 exam, the last year exam. The questions was like this. It's not exactly the same as what you usually see in organic reactions. Usually they give you this chart or flow diagram, but last year in the exam they decided to give something that looks different. It's like two parts. Part one, they give you a reaction like that, and it's cracking. You have to work with cracking. If you forgot what cracking is, you have to remind yourself of that. But it's basically the breaking down of a longer hydrocarbon chain to a much shorter one. And by much shorter one, I mean a couple of shorter molecules that can be very useful for us. Okay. Then question 4.2, in this case, they had a table which contains reaction 1 to reaction 3. And then you are asked questions based on those reactions. If we have time, we can go back and look at that. But we should start with this one here. Let me make this full screen. Okay. So this question says, consider the following sequence of organic reactions labeled A to E. So it seems like we start at reaction A, but we can start anywhere. But this one that I'll highlight looks to be the initial point because we have an arrow flowing down here to D, and then we have another arrow flowing up to compound X here. But we'll look at that as we go, and then I'll give you tips as well on how to actually approach this kind of questions. So the first thing you want to do is you look at where you can actually start. Usually you want to start where we have the actual structural formula of the molecule. That's a good starting point because I can just draw that out and then I can be able to tell what happens, for example, say on reaction A or on reaction D. So let's draw out the one I highlighted in yellow, and then we can be able to also tell the name of that. So I see the first carbon here is attached to 3 other hydrogen, like that. And then there is another carbon attached to that one, and this one is only attached to 1 H, like that. So you can see the first carbon in the chain is attached to 3 hydrogens. The second carbon in the chain is attached to only 1, and then the third carbon is attached to only 2. So if I just draw that one and attach it to 2 hydrogen molecules, what does that mean about the bond that we have between these 2 carbons?
It's a double bond.
It's a double bond. Good. So making this a double bond, then we can see that each carbon is attached to 4 other bonds, which is good. If the carbons are not attached to 4 other bonds, it's not correct. So here it's 1, 2, 3, 4 for the first carbon. The second one is 1, 2, 3, 4 because of the double bond, and so is the last carbon. Okay, so that means the molecule is correct. Every time we try to draw out molecules like this, it's always trial and error. In other words, you draw it the first time and then you check if it really makes sense. If it doesn't make sense, you draw it the second time. You can't always get it the first time, so just make sure that you practice that as well. So they tell me that towards reaction A, I'm actually adding or I'm reacting this with HBr. So if I'm going in this direction, okay, I'm gonna run out of space, I think. But this means that when I go to compound X, I'm basically adding HBr. Here is the HBr that they show here. That's the only clue that I have to compound X. Otherwise, I don't know nothing about that. So I'm going to do exactly that. This is just us breaking down everything. We haven't really gone into the questions, and I do suggest that you do this. You only first need to break down the diagrams. Make sure that you can like break it down as much as you can before you actually go to the questions. That way you skip all the confusions, all the anxiety from like reading the questions and finding something that you might not even be able to do. But anyways, so I'm gonna add HBr, and with this I know that the H is a hydrogen and the bromine is a halogen. So every time we add a hydrogen and a halogen, by the way, halogens are these elements here. If I just quickly go to the periodic table, halogens are these elements on group 17 that I'm just blocking here. So you can have fluorine, chlorine, bromine, iodine, and this AT that we don't really use because it doesn't even have a molecular mass. But yeah, you get my point. So these ones will always be bonded to one bond, as we can see here, and that is what we can attach to our organic molecules. So if we remember, the addition of hydrogen and bromine is called hydrohalogenation. That is from the fact that we are adding a hydrogen and then we are adding a halogen. So what will be the product and what will be the name of this reaction? Do you remember it?
The product.
Yes. So this is called halogenation. Is called what? Is it addition, elimination, substitution, or what? If you do remember,
Addition reaction.
addition. Yes, this is called an addition reaction. So just gonna write on top here for ourselves. This is an addition reaction. So if they ask you what type of reaction is taking place here, you can either say addition or you can specify which kind of addition, and you can say hydrohalogenation. And we know it's an addition because we are going to make the double bond disappear. So you know whenever you're adding that the double bond has to go away. So the product that I expect to get here looks like this. The double bond will go away, and we have a rule for adding as well. It's called Markov-Nikov's rule. I'm not sure if you remember that one.
No.
Okay, the rule is basically simple. It just says to you that when you're adding or when you're performing hydrohalogenation, the hydrogen always wants to go where many hydrogens are. So you can see here on the last carbon, there's 2 hydrogens, and on the second last or the middle carbon, there's just 1 hydrogen attached to that. So this hydrogen from HBr wants to go to a carbon that is already having many friends, in this case 2. So I'm going to take that hydrogen and I'm going to attach it on the carbon with many hydrogens. And the Br will automatically go to the other side of the double bond, which is the middle carbon, like this. And this is called a major product. This is called a major product because of this. Major product. A minor product, if you ask, is going to be vice versa. I'm going to take this one here and this one there. But it's very rare for a minor product to form. That's why we mainly focus on major products. And major products will follow this rule that I just explained to you. The hydrogen, we want to go to where there's more hydrogens. The other thing will go to the other place where the double bond was. So now the double bond is gone and we have our product. And this on our diagram is called compound X. So I'm going to call it compound X. And we can also give the IUPAC name of this. What is the name of this molecule?
I think I forgot what you call the three carbon, but I know it's supposed to be this. Yes, I forgot the third one.
You forgot which part?
The third one, well, like I know like the first one is gonna be this, and then so it's gonna be it, and then the third one I forgot what you have to say.
Okay, so we say let's look at the main chain first. We have 3 carbons, and then the first thing you want to do when you're naming, you want to name the carbons from 1 all the way to the last one. And how you decide which one is your first is you look at where there's a disturbance. In other words, you look at the nearer side where there's a double bond or where there's a substituents, which is just something that is attached to any carbon. So in this case, a bromine will take our attention, but we see the bromine is right in the middle, so we can name from any starting point we want. So this will be my 1, this will be my 2, this will be my 3. So the main chain has 3 carbons. What do we call that main chain, if you remember? 3 carbons or 3 carbons in a straight line. It's called propane, and because there's no double bond, it's only single bond, it is propane. If it was if there was a double bond like this one here, yes, it's gonna be the first molecule. Propene, right? So this one is indeed propene because of the double bond, and the naming of the carbons or the labeling will start from where the double bond is. In this case, that's my 1, this is my 2, and this is my 3. But I don't have to specify there. Why? Because even if I put the double bond here, this thing is just going to be the same thing. It's just rotated. So that's why propene is just written like that. You can, however, call it prop 1 in, prop 1 in. That's fine, but it will never be prop 2 in. So that's why we're gonna leave it as propene. Okay, the IUPAC name of this one will be bromo, because I have a bromine molecule on carbon 2, and I do have to specify that, sorry. So I need to say, maybe let me pull this to here. Then I have to say 2, because it's attached on carbon 2, bromo. And then I don't have a space here between. I'm just going to go ahead and say propane. 2 bromo propane. That's what compound X is. So which part did you say you forgot here on this name?
No, I forgot the prop.
Oh, the prop. Okay. Yeah, you do have to. There's notes in the book that I think the functional groups are given in a table. Just have to keep on reminding yourself of that, because usually, I mean, organic chemistry, a lot of people do master the IUPAC naming part because it's quite easy compared to the other parts. Okay, so we're already done with compound X now. We have an idea of what that is. We can move on now to reaction B or reaction C. I mean, reaction D and C, because if we have, because if we have compound X, now we have the freedom to like analyze any direction that we want here. Okay, this is jumping around, sorry. Let me go back. Okay, I needed a lot of space just to add all the information I want here, but it's fine. I'll just show this. For compound or for reaction C, this is reaction A. Reaction A going in this direction that we call hydrohalogenation or addition. But if we go in the direction of C, you can see C here is going back. If I just do this, you can see C is going back to where we started. So I'm just going to show that as well. If we go C's way in this direction, that's C. So we are going from a 2-bromopropane to a propene. What is that reaction called? When we are going from a bromoalkane or a haloalkane, this is called, by the way, haloalkane, because it has a halogen, but it is a alkane. So we go from a haloalkane to an alkene. This side we have an alkene.
It's elimination.
It's an elimination, yes, of course, and that's correct. It is an elimination. So let me write that down. We have elimination, and then what we are eliminating is we are eliminating these two here, and they will form HBr after we eliminate them. And where they were, there's gonna be a double bond that forms. That's how we know it's elimination. Elimination goes from an alkane or haloalkane to form a double bond. So addition makes the double bond disappear. Elimination forms the double bond. I think I have to write that down in the notes as well for you guys. Addition, double bond disappear, double bond disappear. And then for elimination, double bond is introduced. That's how you know double bond is formed, thereby eliminating those things that were there. Okay, we can specify what kind of elimination this is. By the way, we are removing hydrogen and halogen, so it's called what?
For the dehydro. Yeah, dehydro. Oh, dehalogenated. Yeah.
Yeah, it's basically this one with D added in the front. So it's going to be D hydrohalogenation. That's it. We are eliminating a hydrohalogenation, so we're just gonna put D in front. Okay, good. Then let's proceed. We already understand reaction C. Now we can move on to reaction B or D. Let's just go to D first. So D goes in this way, because once you break down the whole diagram and reaction, everything just makes sense. So I'll go this way for D, and then we'll talk about what D is. And what's nice about D is that they give us a condensed structural formula that we can actually draw out. This is important part, the drawing out of the structural formula. If they give you a condensed molecule, you draw it out. So this one looks like this. Then the third carbon is attached to 3 other hydrogens. So there we go, simple enough. What is the name of this one?
Propane.
Propane, yeah, simple. This one is just propane. So from where we started with propene, we end up with propane. So what kind of reaction happened there? Where we start with a double bond and the double bond disappear.
Addition.
Addition, there we go. It's also addition. And then we can specify what kind of addition. What do you think?
I think it's the.
Look at the things that were added. Here is the things that were added.
It's hydrogenation.
Yes, there it is. So hydrogenation, because we are only adding hydrogen. Hydrogenation, or just addition of 2 hydrogens. Okay. All right, there we go. We finished D. So if there's a question about D, we can be able to actually write it. Okay. Then let's go to compound B. I mean, when you gain experience with this, you don't really have to just go out of your way to actually fill up everything. You can go to the questions just to save time. But what I'm doing now is just to teach. So you'll see when you gain experience what you can do to be quick here. Compound X forms compound Y or alcohol Y, which you can see they say there's a major product, and they also want us to explore the minor products. Okay, let's go to compound X and see what we can do. Compound X was a haloalkane, so I'm gonna go through this path to alcohol Y. Then I'll say, okay, this side is alcohol Y. And it should be a major product. Okay, we don't have the actual structural formula, but we can come up with it. This, by the way, is reaction B. Let's see. We are forming an alcohol from a molecule like this. What should we do? Or what is this reaction called? What I know is that the first carbon is gonna stay the same. So I can draw that out. Then the second carbon, I can put the H on top here. The third carbon also has an H in it, 3 H's, so I know it's always going to stay the same. So what is the thing that changes is the bromine part. That is the one that is going to be kicked out. So when we kick that out, what are we actually adding here on this carbon?
H2O.
Not really H2O, but OH. I'll show what happens to H2O. But in the reaction itself, we are adding water. So we are adding water. And when we do that, the OH is going to go and attach to this carbon, while the other H, because here I'm pulling away the OH to go here, the other H will combine with the Br that came from there to again form HBr. I don't know if that makes sense.
Yes.
Yes. So what kind of reaction is this?
Addition.
It's not gonna be addition. Why? Because I'm not having a double bond before. I'm only having single bonds from here on. So what happens when I go from single bonds to single bonds?
It's substitution.
Substitution, yes, exactly. Because we are literally just substituting something that was there with another thing. So this is called substitution. Let me write it up top. Substitution. And okay, let me check something here. Just wanna see the kind. Oh, actually, yeah, they do have a question about reaction B, so let's go a little bit deeper into that. So it is substitution because, oh, again, the notes for substitution, we have to say that substitution is pretty much just explains itself. We are replacing something, replacing a molecule of, let me just say we are replacing something with something else. So this one will take alkane to alkane, or single bonds. I'll just leave it here. It's gonna be all single bonds. Every time we see that it's all single bonds, we know it's substitution. Okay, what kind of substitution is it when we are adding water? Any idea? Okay, it's called this hydrolysis, because we are adding water, and the lysis part has to do with substituting whatever was there before. So we are or we call this hydrolysis. Okay, do you have any question?
Yes. So is it because like the reaction itself is with alcohol plus HX, the product being a haloalkane plus H2O.
Okay, you said alcohol plus
HX, and then product being haloalkane plus H2O.
yes, that's correct. So that's
Okay. That's how I wrote it.
yeah, this one will be also a type of substitution, because these things will be all single bonds. Okay. And
But then is that Is that hydrolysis?
No, hydrolysis is only when we are adding water. If we are eliminating water, it's called is it dehydration, or let me remember, I think it's dehydration, because D means removing, hydration or hydro means water. So I'll confirm, but I think it is dehydration. So we are removing water. Okay, that will be the vice versa of reaction B. Say if they had an arrow that actually points back, that will be what we were looking at. Okay, good question. All right, fine. Then yeah, we are finished drawing the major product, and we know it's a major product because instead of eliminating this H, the OH actually eliminated the, okay, instead of being attached here, the OH is attached where there's less hydrogens. Remember our minor product for compound X. Minor product for compound X. This will help us identify the alcohol Z minor product. Because let's see. We said, according to that rule I said, Markov-Nikov, compound X could look like this. Br coming here and the H coming there. So when I add water, that water molecule, or the OH part of that water molecule, is going to eliminate that Br there from compound X to form a minor alcohol. So let me copy this one and paste and do the editing for the minor alcohol. Copy, paste that there. So what I'm saying is that now the OH is not going to be here, it's going to be right here. That's how we know it's a minor product. That is very unlikely to happen. That's why we call it a minor product. Okay, need to also edit this to say minor. Okay, and that is our compound Z. It comes from compound X minor product. This is, by the way, compound X minor, which if I add water will become compound Z minor. Does this part make sense?
Yes.
Okay, good. So now I can get rid of this one, and then we can show this one because the reaction proceed forward. It goes to which one? It goes to E, which forms something that we are given a formula for. Let me do that. Let me actually copy down the formula. C, we have H3 and, okay, sorry. Okay, let's see. Oh, and yeah. Okay, let me just draw out this compound, the last compound, C, H, H, then another C, H, H, and then there's O, O, C, C, H2. So we know something is happening there, but once again, it's trial and error. I should have actually given you a chance to draw this out, but we're gonna have two oxygens. We are looking at this one, right? We're going to have two oxygens, and then they look to be attached to a carbon. So immediately what comes into my mind is that this molecule has to look like this. There's the two oxygens and the carbon they are attached to. I should highlight this with yellow as well. That's what's going on there. Then there's another C attached to H, and then there's C, H. Okay, then I want to copy this and paste it on our flow diagram. So from this minor product, we go to this thing that we just drew. And this is following reaction E. Okay, good. So we haven't really named compound Y yet. So what is the IUPAC name of this compound Y molecule? This one.
Prop is 2 on.
Yes, so this is prop 2 on, all. Actually propan, because it should be propanol. But if I have to put that 2 in between, it has to be propan 2-ol. Okay, propanol, propan 2-ol. Then what about the minor product? What is the name of this?
Propanol.
Okay, I'll give it to you, but we do have to specify because the OH can move as well. So now I'll start my naming from the far left, from the far right, because that's where a disturbance is. Then this becomes propan 1-ol. And we have to specify because there's a possibility of this being propan 2-ol. That's the only reason why we specify. If it was ethanol has two carbons, then you can see that way we don't have to specify because the OH can move, but the name cannot change. We're just going to change where we start to number. This is 1, this is 2. But if the alcohol now moves to this other place, then we just need to change the numbering, but the name stays the same. Okay, I think you get the point of that. All right. So now we know the name of compound, alcohol Z. Now let's focus on reaction E, which is the last thing we'll do today. Reaction E seems to be taking this propan 1-ol and making it this molecule. First, let's talk about what is the name of this. Let me check if I actually wrote it or drew it correctly here. Oh yeah, did I miss something? Wait, CH3 1 2 3, and then there's 1 2 3. Yeah, I actually think I missed something. No, I didn't miss anything, except I made a very bad mistake here. I can see this because of the alcohol that I start with. This compound here is called an ester. Do you remember esters?
I mean,
Yes. So esters are made of an alcohol and what else?
can you please repeat the question?
Esters are made of an alcohol and what else? We are right here.
Like, carboxylic acid.
Carboxylic acid. That is correct. So if the alcohol that I have is this one, what you have to remember is that this part of the molecule is the carboxylic part, and this part of the molecule is the alcohol part. How do you tell? Is this the carboxylic acid has a functional group that looks like this: C double bond O, OH. So every time I see a double bond O, I know that that part is the alcohol, is the carboxylic acid part, and that the other side is the alcohol part. Now, when I look at my alcohol, it has 3 carbons, but what happens here on the alcohol side? I see only 2 carbons. Can you see that there's a mistake there? Yes, that's why I say this thing is trial and error. When you're drawing the molecules, it's always trial and error. And then if you know what you're doing, you can always fix your mistake. So now I'm going to do this. I'm going to take this H. I just move things around a little bit. And then I take the oxygen and plug it there. I take this one and plug it there. Now my molecule is 100% correct. And they give you a clue here. If I just go a little bit back here, they give you a clue of where the C with the double bond O is. You can see it's on the other side. I had it on the first side initially, but that's fine. It's trial and error, and you can always fix your mistake later. So now it's correctly represented. The C is on the other side. So now this side is the alcohol part, this side is the carboxylic part, and I see that the alcohol has 3 carbons. That is expected. So let me write alcohol side, carboxylic acid side. Then I can now name this ester because I know the alcohol that was used. It's propan 1-ol, and I know the carboxylic acid that was used. By the way, what is the name of this carboxylic acid that was used?
The what?
The carboxylic acid that was used. I'm not sure if you can hear me. Is there a problem maybe with the audio?
Don't really.
Can you hear me fine? Because on my side I can hear you very well.
Yes, I can hear you very fine. It's just like I was doing something else like writing.
Okay. So we're looking for the name of the alcohol that was used, this part. I mean the carboxylic acid that was used.
Okay, yes, I.
No. Look at this. It's still 3 carbons, which means it has to do with prop. Okay, this tells me you forgot how to name carboxylic acids. But carboxylic acids always end this way, and if I have 3 carbons, that means it's propanoic acid. That's it. Propanoic acid. Because carboxylic acid always end with oic acid. Okay. Yeah, I really don't want you guys to forget these parts. The IUPAC namings should really be up and place. that is the one thing I could never forget, even though I went, like I did my matric a long time ago, but I can't forget the IUPAC naming part. That's like the easiest of them all. When people love organic chemistry, they love these parts. So I want to encourage you to actually remind yourself more about this. When you have free time, just go to your book, open that page where they have a table of alcohols, the endings, the prefix, the suffix. Learn those things. Just practice more and more. Because now we identify the alcohol and the carboxylic acid, but I'm not confident that you can name the ester because you couldn't name the carboxylic acid. But the ester,
Owing.
yes,
Like an owing.
or you can actually name it.
Yes. I just didn't understand the question that you're asking.
All right. So what is the complete name of the ester?
It's a I said it's an owing.
Say that again.
It's an owing.
Oh no. We have to input the alcohol part and the carboxylic part into the name. We have to add those things. We don't want to count the number of carbons because there's an oxygen disturbance in the middle. We have to put the alcohol part combined with the carboxylic acid part. So this becomes, and once again, you go back and revise these things. The alcohol part becomes propyl. That's what we do to it. We put a YL and then we put a space, and then the carboxylic acid part becomes propanoate. That's how to name an ester. The alcohol part is cut off to give YL, and then the oic acid is cut off to give off OH. So propyl propanoate. Propyl propanoate. Okay, makes sense? Does it make sense or no?
Yes.
Yes. So you can see where you have to revise, right?
And if I can see the style and how to
Yeah. Okay, so that's why I encourage you guys to always attend lessons so that you can identify the parts where you have to redo, things like that. So we did establish that reaction E is esterification. Esterification is just the reaction whereby we are taking an alcohol and adding a carboxylic acid. So they can ask a question and say, what acid did we add? And you're going to say it's propanoic acid, because you know that the product looks like this. This product was given to you. Just the name wasn't given, but they can give anything they want. Usually they don't want to give you this condensed form. They give you the answer. They can say propyl propanoate, and then you have to work out how propyl propanoate looks like, and then that will tell you the other things. So we are done breaking down everything. I see our time is gone, but that's mainly because we joined late. But we can go through the question and see if everything is answered, and you'll see everything is pretty much answered. 4.1, write down the type of reaction that occurs at A and C. We answered that. Write down the name and formula of the catalysts. Oh yeah, that is the other thing that you have to really learn. I tell you the truth, these ones are not easy to remember. Not easy to remember. I'm not gonna lie to you guys. So compound D, reaction D was addition or hydrogenation. This is this one right here. And the catalyst that we need is platinum. You'll see that in the notes. But once again, if there's any marks you have to lose, just make sure it's this kind of reaction, this kind of questions, because it's very hard to remember these things unless if you have a good cramming memory. Okay. 4.3
It's
quickly.
always platinum.
Yes.
It's always platinum and nickel. Right?
Sorry.
It's always platinum and nickel.
Oh,
Or nitrogen.
yeah, for hydrogenation it's always platinum, but for these other things it's gonna be different. We're gonna look at some of those conditions as well. I'll remind you, and I'll also send you the notes. I think you are good at remembering or cramming, so this will work out well for you, I think. Okay. Reaction B is a substitution. We already said that. In the presence of water. Yes, we did talk about that. Write down the type of substitution. We did say it's hydrolysis, if you remember. I'll send the notes as well. So 4.3.2, write two other reaction conditions. You see, here is reaction conditions again. Wait, I think someone is trying to join. I don't know. I didn't think I have a lesson now. Let me see. Oh, no. So it's fine. Then the two other reaction conditions that we need for, again, reaction B, if I just go back, it's hydrolysis, which is substitution. So what condition do I need for that? I can tell you right now, but again, you have to go back and remember them. I'll also send you the notes, which is a good summary for this. You need a dilute strong base. Dilute. This is always the case for substitution. Dilute strong base. And the other thing that you need is heat. A lot of the time you'll see this. They'll give an arrow and then they say NaOH dilute, and then they also give you this thing. This means heat, and that's the reaction conditions that you need for that. Then I'll quickly move off to 4.3.3, IUPAC name of the major product Y. Again, we answered that one. If you remember, it was propan-to-ol, the major product. So propan-to-ol for that, and that's the correct answer. 4.4, use structural formula to write a balanced equation for reaction B, showing the formation of alcohol Y. How does alcohol Y form? This is through compound X and product Y. So they are basically asking you to show this whole process. You're gonna draw these structures to show the formation of propan-to-ol from 2-bromopropane. Okay, so that also we have. You can see once you break down everything, you have everything in your hand. Okay, then they say reaction E is a reaction between a minor product, alcohol Z, and a carboxylic acid. We already know these things because we broke down the question. Then they say write down there, 4.5.1, the name of this type of reaction. You remember the type of reaction is esterification reaction. So esterification is also called condensation, but I'm just gonna write it, but I don't recommend that you use that word. It's very unclear. You can always say esterification and that's fine. Okay, so then we move on to 4.5.2, which says name of the or the inorganic compound formed during this reaction. Inorganic compound is a byproduct that is not really organic. So if you go to esterification notes in your book, I'm just trying to be quick because our time is out. You'll see that the carboxylic acid, when it comes and meets the alcohol, they are going to eliminate the OH from the carboxylic acid, or here's a carboxylic acid. It's going to take out the OH, and then from the alcohol, it's going to take out the H. So a byproduct is H2O, which is water. That is always a byproduct of esterification. Let me write it here in the notes that I'll send to you. Byproduct or inorganic product is always water. Okay, that you just have to remember because it doesn't change. Then name the catalyst that is needed for this reaction to actually proceed. And here it's sulfuric acid. But once again, you can see how they like these questions. And it's a handful, I can't lie to you. I hated this kind of questions in the exam because you have to remember all these things that do not actually form part of the understanding. They are just things that you are adding, like catalysts. It's like, 4.5.4, the IUPAC name of the functional isomer of the ester formed. Okay, now this is an interesting question. IUPAC, the isomers and functional group of isomers, we have these groups. We have ketone, aldehyde. I'll come back and redo these things because now I'm really trying to speed up. Ketone, aldehyde are friends. Another friends that we have is an ester and a carboxylic acid. I call this isomer friends. Functional isomer friends, to be specific. Functional isomer friends. So if they ask you what is a functional isomer of an ester, you always know that it's a carboxylic acid. Always. There's not going to be a change there. If they say what is the functional isomer of a ketone, you always know that it's an aldehyde. That's it. That's all you have to remember. So the functional isomer of the ester that I have here, I won't draw the full thing, but I'll show you what's gonna happen. I do have notes on this, very good notes on the PowerPoints that I make. But what's gonna happen is that the double bond O and OH that you had here will actually move to the end, making this a carboxylic acid. So now if they are requiring the name of that, I know that I have C1, 2, 3, 4, 5, 6, which is hexanoic acid. That's the answer they are looking for. But if there's anything you have to take away, is that a functional isomer of an ester is a carboxylic acid. A functional isomer of a carboxylic acid is an ester. Okay, cool. So to answer this question, we're going to write hexanoic acid. Then the last question, draw the structural formula of the functional group of carboxylic acid. That's pretty simple. We already drew that one. Double bond O, OH. That's it. Okay, and this marks the end of the lesson. I'll upload the recording as well as the notes. Oh, here's the thing. I don't really like to upload the notes. Why? Because I want you guys to always watch the recordings. So I don't promise that I'll upload the notes, but the recording definitely I will upload it. Okay, cool.